What is the best reality for my application? How do I decide if I create a virtual reality app or an augmented reality application? Think about your use case. Can your users sit on a chair and be immersed and completely disconnected from their environments and see a simulation for education purposes, for example? Then that's a very good VR use case. But if you have to have some kind of connection with your actual environments, then augmented reality should be your choice. A great example is if you are educating a surgeon for a surgery, that's a really good use case and that you can practice in a virtual environment. But when you're in a surgery room, you can't be disconnected from your environment totally, but you might need to have some relevant information in front of you about the patient. And that's a really great use case for augmented reality.
Good morning, good afternoon, good evening, everybody. Thank you so much for being here today. We begin the session 2 of this amazing XR Global Conference. And today we're going to be speaking with Dino Fejsajic. He is going to be teaching about how to implement the right way locomotion systems for your app. So let's begin. He is very excited to be here today. And we're going to be discussing how step by step, how to do it in Unity. Thank you so much, and let's get moving.
the tools that you can start learning to develop for mixed reality. There is a great selection of tools. One of the very popular one is Unity Engine. It has a great UI which allows you to drag and drop objects or assets and create your applications right at the UI level. But if you want to add more behavior to it, you can create some scripts with C# in Visual Studio and debug your application there as well. And we have an emulator for HoloLens that you can use directly from Visual Studio. Another great tool that we are supporting now is Unreal Engine, and it's a very popular tool among designers. And if you're developing for the web, we have multiple choice. Babylon.js is a great library which has amazing examples and a playground that you can start playing with. 3JS and A-Frame are two other very popular libraries that you can start playing today. You can choose from any of these tools to get started with mixed reality.
Hello everyone, I'm down here in your bottom right screen corner. Thanks for tuning in to my session about the Locomotion system in the XRTK at this year's Global XR conference. First of all, let me say that I'm sorry about my audio quality. I moved into a new place and for some reason in my new office I have quite the echo, and yeah, so I need to figure that out. I wasn't able to really solve it yet, and the lighting as well, but I think it should work out. So what are we looking at today? We are looking at the Locomotion system, which I developed for the Mixed Reality Toolkit, but pay attention, it's not the MRTK, it's the XRTK in this case. And it's part of the latest release of the toolkit, and it replaced the old teleport system and is now a much more sophisticated and versatile system for use in your applications to move your user around. So yeah, without any further ado, let's get started. I am in Unity editor here. It's Unity 2020.3, the current LTA long-term support version. It's an empty project. It's pretty much empty. It actually contains the example I want to show, and just a bare bones toolkit imported and configured. And I will actually show you a pre-recording I made of what we are looking at today. So I will just play this and pause here and there to explain. So we are looking here at the demo scene I set up for the Locomotion system in XRTK, and it contains a bunch of teleport locations and a little UI to switch teleportation providers, which we will talk about in a minute. As you can see, I have my controller gizmos, placeholders. It's a kind of room with some podests in it, and now what you see now is me performing smooth locomotion or free locomotion. I basically just use the left thumbstick on the left controller of my Oculus Quest 2 device to move around wherever I want, and You have seen this in plenty of VR applications probably. I'm just moving around and I can use my gaze, so wherever I'm looking at, to impact where the locomotion is taking me. Now what we are seeing next is me doing teleportation. Nothing extraordinary here. You've seen this a lot of times as well, probably in other applications. I'm just using the right thumbstick in this case to move around and select a location to teleport to. Now these blue squares on the floor and on other places, they are what we refer to as teleport anchors. I think in other toolkits it's called similarly. So it's just predefined teleportation locations which you can use to predefine an orientation the camera rig should take when it's teleporting to that specific anchor, for example. And using my right controller, I'm now selecting dash teleport in this menu, which means I'm switching the active teleportation provider. Let me show you that in action for a second. Yeah, so you've seen previously I was just kind of instantly teleporting to a new location. And in this case, now that I have dash teleport enabled, I'm actually moving smoothly to the predefined location. It feels a little like free locomotion, but it's basically still teleport. And there's one last in this example, which is blink teleport. I'm going to show that as well. So you can see it's kind of like blinking your eye, like you were closing your eyes, and when you open them up again, then you are at the new location. And what we are seeing here is you can use the thumbstick if you press it with your thumb, and then you can use it to manipulate your camera orientation after teleport. So this little arrow here, it specifies where your camera will be looking at, in which direction, when the teleport is complete. Yeah, so these three teleport providers, they come out of the box with XRTK. I have pre-implemented them, and as you can see, you can change the active provider at runtime if you want to offer your users maybe different kinds of teleportation or locomotion in general. Some users might be used to locomotion and are not as VR sickness doesn't affect them too bad, so they are maybe able to use some locomotion provider that is, let's say, more fancy, more fitting to your application, but may cause VR sickness. Some users just aren't used to VR, and with users that are pretty much new to VR, you could be using a locomotion provider that reduces motion discomfort and etc. So all of this comes predefined with the toolkit out of the box. You don't have to worry about it at all. You can just use it if this is what you need. And this is also kind of what this session is about, is showing you that XRTK comes with a lot of useful stuff that you can use, so you don't have to re-implement everything on your own. In general, my advice is, when you are starting any XR application, don't do it from scratch, don't reinvent things. There's plenty of toolkits out there. You have to find the right one for yourself. I'm using regularly the MRTK, I'm using the XRTK regularly. So those two are my toolkits of choice, but there's others. There's the VRTK. Unity has their own toolkit at this point, which has a lot of useful features. I haven't looked into that one too much, so I can't compare it to XRTK actually, but You should take a look at any of them and then decide which one to use. But my recommendation is take a look at XRTK. It comes with a lot of useful features. So let's close this. As I mentioned earlier, I pre-recorded this on my Oculus Quest device using Airlink, Oculus Airlink. Do I actually get to call it Oculus Quest still? It's the Meta Quest 2 device using Meta Airlink. Yeah, I pre-recorded that, and now we are back into the editor. So I was just pressing play here and then recording. It's always better to pre-record these kind of things when you are doing sessions, because you never know what might go wrong. So I'm not going to talk too much about XRTK in general and how to get it into your project, etc., because there is another session of mine at the Global XR conference, which is tomorrow. So that one's, I think it's called XRTK Getting Started. So you should take a look at that tomorrow if you want to learn more about XRTK. Still, we are going to take a look at some of the foundational stuff that we need to understand the Locomotion system. So, as with any XRTK-based project, we have our game object called Mixed Reality Toolkit in the scene, which contains our Mixed Reality Toolkit worker, let's call it like that, the service locator, and where we also get to configure everything. And we have the XR camera rig, which is our camera rig. Surprise, surprise. This will look familiar to anyone that is working with MRTK. It's quite similar, but not the same. We have a couple of systems here enabled, which come out of the box with the XRTK, which is the camera system, diagnostic system, input system, locomotion system, the one we are talking about today, the boundary system, spatial awareness. This one you'll not be getting. This is, you get this one if you are importing the examples project into your application or your Unity project, but it's not meant to be delivered with the core package. So we have the locomotion system here. If it appears in this configurations profile, that means it's active. So we can now select it and open it. And inside here, we see how it's configured to work at this point. We have a teleport cooldown, which I added so you can specify how many seconds need to pass before your user can start another teleport. It defaults to 0. If you set it to 1, that means your user teleports, then he has to wait for a second, and then he can teleport again, or she. And then that's basically it for the general configuration, and then it's all inside the providers. The system, the locomotion system, is your main interface, but its features and functionality are a composition of several providers and subservices that make it work the way it does. We have, for example, by default, a teleport validation data provider. If you open that one, then you can configure how does the system validate whether a target location your user wants to teleport to is a valid location. You can configure max distance, how far can you use the teleport, max height distance, so that means from the camera rig's position, how far above can you use a teleport. It's set to 10, that means your user will be able to climb up 10 meters, for example, but he won't be able to go above that if you don't raise the limit. This is just to determine whether a surface is flat enough to teleport to, just as the tooltip says. And we have some invalid layers configuration and valid layers configuration, which specifies raycasting layers, Unity layers, physics layers to consider valid or invalid for teleportation. And last but not least, You can also set anchors only. That means that your user will not be able to teleport to any valid target location, only to anchors. So in the example video I showed previously, I was able to teleport everywhere, including anchors. And if you set this, you can just teleport to anchors, which makes sense in many scenarios. Then let's go back. And then we see we have a smooth locomotion data provider, dash teleport locomotion provider, blink, and instant. That's the three that we saw in the video earlier. Let's look at the smooth locomotion data provider. And we can see that there is some general settings. Every locomotion provider will have these general settings, which are startup behavior and input action. Startup behavior means you have auto start and manual start. That means, will this provider be active when my application starts? In this case, it's set to auto start. That means as soon as the application launches, this provider will be active. This might not be what you want in a production application, because you want maybe to restrict the user to not move around until he has finished or she has finished some tutorial, etc. So you kind of probably want to have this on manual start in many cases. Input action is the input action, mixed reality input action that we want to listen to trigger this teleport. And last but not least, speed down here is a specific setting for the smooth locomotion data provider. And it's how fast in meters per second does the user move around when performing locomotion, smooth locomotion. Let's go back, and then we see we have the dash teleport. Same thing. This one is set to startup behavior manual start, and it has also its own input action. It also has some dual single axis input action settings. This means that for teleport, we are using either single or dual axis input actions, or you can even use a bool input action like true or that just has a true or false state, like a button. So why would you use a dual axis? Dual axis is useful because you get a cool feature that you can select your orientation at the target position. This is only possible if you are using dual axis input actions, because it will then read the dual axis input of the thumbstick to specify the orientation. If you use single, then some of these settings will take effect as well, like input threshold. If let's say you set your Oculus trigger to be, where's my control actually? So yeah, stupid me, I have the controller right here. So let's say we have this trigger here, then we can say that the user has to press it halfway to start the teleportation. And if we have a thumbstick, then we can also specify an input threshold. How far does the user have to push the thumbstick to actually trigger input action? You can also use buttons, of course, which is just, if you press it, it's triggered, and if you don't, it's not. We have dash duration. This is again something specific to the dash teleport locomotion provider, because it specifies how long in seconds does it take for the user to reach the specified target destination. Let's look at blink. So blink is, I'm not going to talk about these again. These are also same settings. All teleport providers have these single and dual axis input action settings. So the blink one, it also has a fade duration for the blinking. It has a fade material. You can use this to change the material used when that's used for fading. This is useful when you are using, for example, the universal render pipeline or the HD render pipeline. Then you can update the material, for example. or you could use some shadograph materials that you created to make it more fancy, etc., etc. And you can specify fade in color and fade out colors. This is just black and black transparent, kind of clear. So go back. And last but not least, obviously this one doesn't have any specific settings. It's just the general settings and the input action settings that all teleport providers share. So as you can see, this one is set to auto start. That's why our in the video, in the example scenes, the default teleport provider is the instant teleport. The other two were set to manual start, and this is something we need to talk about. There's three kinds of locomotion providers that the locomotion system understands, which is free locomotion. One example of free locomotion is the smooth locomotion data provider. And then there is teleport locomotion. And then there is on-rails locomotion. While the locomotion system supports on-rails locomotion, it doesn't come with a default provider at this point, because I've figured it's very specific and I wasn't able to come up with some general use on-rails locomotion provider. If you have an idea for that, please let me know. I will gladly add a default implementation for that to the toolkit, but for now it supports them, but you will have to implement it, and I will show you how later. And then we have these teleport locomotion providers, and why I'm saying this is that there can only ever be one active teleport locomotion provider. So you cannot have dash and blink enabled at the same time. If you do that, if you configure this one to auto start and another one, then just whatever is the last one that's enabled will be the enabled one. And they are enabled in the same order they appear in this list. So if all of these three are set to auto start, then in the end, instant will end up being the active one, because as soon as it enables itself, it will disable the other two. I hope that makes sense. So you can have a you can have a free locomotion provider active, and you can have at the same time a teleport locomotion provider active, but you can have only one of each category. So you can also not have two free locomotion data providers at the same time. Also, on Rails locomotion is exclusive, so as soon as you enable any on Rails locomotion provider, all the others are disabled. I figured that makes sense. So when I was implementing it, because when you have on Rails locomotion, you don't want your user to move around freely. You also don't want the user to teleport somewhere else. On Rails is usually some roller coaster or car scenario, so you don't want the user to move around except the way you implemented it in your on Rails provider. And that's about it for the configuration of the locomotion system. Let's take a real quick look at the input system here to see why things work the way they did. In the input system, we have the Oculus controller data provider, which is responsible for reading input from the Oculus controller. And if I click on that, and let's select the left one, then we see here that the primary thumbstick, this one, is configured to the movement direction input action. That means when I press that stick, when I push it, I don't press it, I push it, then movement direction input action is fired, and it will contain the information on the dual axis, how far has the thumbstick been pushed. Let's look at the right one. So as you can see, the right one has teleport direction instead of movement direction, and teleport direction was or is the input action our teleport providers are listening to. and because we configured them to do so. And that's why things worked. So on my right hand, I have teleport, and on my left hand, I had free locomotion. So let's go back here. And that's pretty much it in terms of configuration in the inspector. All of this comes out of the box the way it's set up right now. And we will take a look at some of the code next. Ready to look at some code? Boom. So what we are looking at now is the UI Locomotion demo script, which is essentially the UI controller for that little UI window we were seeing in the example scene, where we can select different locomotion providers. Why am I showing you this? I'm just showing you this so you can see how straightforward and easy it is to change the active locomotion provider. Because if your application has more than one provider, then you will have to do this in code, so changing the active locomotion provider. And you can do that easily by just getting a reference to the locomotion system using XRTK.tryGetSystem or getSystem if you are sure it's there. The tryGetSystem is intended for use when a system is let's say optional, and you can then check if it's there, and if it's there you can enable some feature or disable stuff if it's not. Yeah, so this demo obviously requires the locomotion system to be available. We get a reference, and then this little update loop will just make sure that the UI canvas is always looking at the user. But where it gets interesting is down here. So we have blink teleport on click, dash teleport on click, and instant teleport on click. If you press those buttons, they will this handler gets executed, and then it just calls locomotion system, enable locomotion provider, and then it passes the type. So let's take a look together at the interface of the locomotion system, because this is your first point of contact with the locomotion system. Probably you'll be getting the system reference, and this is what you work with. So you can check whether teleport is cooling down. You can also get a read-only list of all enabled locomotion providers at the current time, and you have several options of enabling a locomotion provider using the type. And also you have options to disable locomotion providers. You have those two you probably don't care about because they are actually callbacks by the locomotion providers to the locomotion system. So the locomotion system knows which providers are enabled and disabled. And also you don't care about these. They will also, this is just for communication in between providers and locomotion system. But obviously, if you have a use case for them, you may use them as well. And that's how you switch locomotion providers. Now let's take a quick look at the Blink teleport locomotion provider and how it's implemented. When you are implementing your own locomotion provider, then what you want to do is that you have to subclass your implementation from, for example, base teleport locomotion provider. This will give you a head start with some boilerplate code that is required for teleport locomotion. If you are brave or you have some advanced use case, you can also decide to go one level down the tree, which is the base locomotion provider. So this one will give you a free even more of a free hand in implementing your provider, and just make sure that you implement the proper interface. So there is an interface for iTeleport locomotion provider, which is obviously teleport locomotion. There is iFree locomotion provider. Make sure to implement that one if you are looking to implement a free locomotion provider. And there's iOnRails, obviously, and as I said, iTeleport locomotion provider. Now this one does enforce one property and one public interface method that you have to implement for teleport locomotion to work. But I think that's okay. Other than that, you are completely free in implementing how your teleport works or how any of your providers work. But back to the Blink teleport locomotion provider. This one, it has its own profile, which is the Blink teleport locomotion provider profile. It gets it into the constructor, and essentially what we are doing here is just saving some configuration properties that I showed earlier in the inspector, fade duration, fade material, etc. When enabled, it will initialize a fade sphere in code. That means it will put a sphere around your camera, around your head if you want, and that sphere has its normals pointing inwards. That means it's not visible. That means it is visible from the inside. And we use that to kind of fake that blinking effect. So that sphere will fade in when teleporting, then it will teleport, and then it will fade out that sphere again and disable it. So it initializes that fade sphere on start when it gets enabled. I believe since enable may get called multiple times, that we check. Yeah. So we are checking if the sphere already exists, and if it already exists, we're not doing anything. And yeah, so then we get some callbacks that our teleport provider gets from the locomotion system. So when the locomotion system requests a teleport, the user requests a teleport, then this provider will get an on teleport started callback. And it will actually check if the request is for this provider. So why is this important? It's important because there might be a teleport request that is not for this intended for this provider, and that's where we check if we are actually listening for a teleport to start. Let's take a look at open targets requests just real quick, so we don't get confused. It's inside base teleport locomotion provider, and what happens here is that we keep track of target requests that we have sent out. Because it's an asynchronous process, there is this thing called iTeleport target provider, which we haven't talked about yet, but it's essentially another component that is responsible for providing a teleport target location. So essentially the teleport provider is just responsible for moving the camera, the user, to the specified target location. But the teleport target provider is actually the one that helps decide where this target location is. And in our case, with the scene we were seeing, is the teleport target provider our pointer. There was this pointer that was on the floor, the parabolic line with the arrow, and so that is where our teleport target provider was sitting on, which is a default. So the XRTK pointer is a default implementation of teleport target provider. So why did I decide to extract this interface? Is that you may come up with use cases where you want teleport targets to be provided by, I don't know, a ball that you throw, and then wherever it lands, that's where you're teleporting at. So you might not want always to use pointers for this, and this interface allows you to do that. So you create whatever you want component wise, some component, attach it to a ball object, and then make sure that you implement iTeleport target provider and that you register it with the Locomotion system, and voila, then you can provide teleport targets that way. So yeah, we keep track of that here, of available target providers. We might have more than one teleport target providers available. And then we keep track of open target requests. So the user presses the input action, which raises a teleport request to providers. And then any provider that's available and considers itself responsible for that request will raise its hand and say, look, I'm here and I'm able to provide you a teleport target. And the teleport provider will then wait for that target provider to send a message back with the target location. And once we have that, we will then get our on teleport started, and then we can check if we have an open target request. If yes, then we can just start doing whatever our teleport provider needs to do. So we fade out, we check if there is an anchor, a teleport anchor, and have to do some logic here, but that's essentially not nothing special. And then we have on teleport completed. Once it's completed, we fade in again, which means we fade in the camera, and we can also cancel, obviously. And the actual perform teleport, which is the core of this provider, is here. It's just moving the locomotion target to the target position that was specified by the target provider. So I know this sounds confusing and like a lot, but it's essentially quite straightforward. Let's take a look at instant teleport locomotion provider, because as you can see, this one is really down to the bone. So we have an instant teleport locomotion provider, and it just gets a callback on teleport started, which tells it, okay, teleport operation was started. We again check if we have an open request. Did we raise a request for a teleport target? If so, then we just move the camera to that position and we raise teleport completed when we are done, which is in this case instantly. So let's one more time go back to blink teleport. In this case, we don't raise teleport completed right away. Instead, we fade out. We just does some stuff in this update loop. It lerps the colors, whatever. And then when we have faded out, then we perform the teleport. And when we have performed the teleport, only then we raise teleport completed, which in turn will give us a callback on teleport completed, which we are listening for, and then we fade in again. And then our base implementation will make sure to clean up all the temporary events we registered for and stuff. So that's why I'm saying make sure to use base teleport locomotion provider, because it takes away a lot of the boilerplate stuff that you need for teleportation to work. And when in doubt, please look at the instant teleport provider, because this one is really what you want to look at for the bare minimum of code needed to implement your own teleport provider. And for the sake of completeness, let's just take a real quick look at the dash teleport locomotion provider. This one will, again, similar to the blink one, when teleport starts, we check if we have an open request. If yes, then we start dashing to that target position. And once we have reached the target position, we raise a teleport completed and we are done. So those are the three default implementations that come with the toolkit, and how you can enable and disable them as needed. And we will take a look at implementing your own later. Yeah, so just for completeness, let's take a quick look at the teleport target provider interface. This is the interface you will have to implement when you want to implement your own target provider. But as I said, it can be anything. Just implement the interface and check how the default implementation does the registration, and you're good to go. By the way, iLocomotion System Handler is also a very useful interface that you can implement to make your any script, any game object listen for teleport events. So you might have some piece of logic, some scripts in your game or application that need to know when teleportation happened. They don't need to implement it, but they need to know when it happened. You might want to play a sound effect when teleport has completed or when it started. And you can use this interface to implement it on any mono behavior and register the game object to communicate over these events. So let's take a look at the base teleport locomotion provider, because all locomotion providers actually implement this interface, which should be here. Is it the iLocomotion? Oh, yeah. So all locomotion providers implement iLocomotion System Handler. And that's some input events we need to listen for, but you don't have to worry about that. Yeah, so where was I going with this? I was looking for base locomotion provider, I'm sorry. So this one is the base for any sort of locomotion, and it has some useful properties like locomotion target transform. This will be by default your camera rig. It also has the camera transform if you need to do anything with the camera directly. By default, usually it's recommended to parent your camera to a parent object in mixed reality applications, which also comes by default with the XRTK. That's why this transform and this transform might not necessarily be the same. And when we are enabled, then we essentially just check for our startup behavior, and if we are configured for auto start, then we just enable ourselves. Okay, so that was a lot of code really on a quick run, but I encourage you to look at the existing code for existing implementations to learn how you can extend the system and create your own types of locomotion. If you have an idea for a locomotion type or implementation that you feel like is very important and should be by default part of the toolkit, please let me know. I'm looking to add more and more locomotion providers with time, so people don't have to worry about implementing their own at all. So please let me know if you have any ideas for more generally used locomotion providers. After I was done recording the last bit, I realized I had forgotten two things, which I want to make up to right now. So there is one component that you can use, which is locomotion target override, and it's a mono behavior. You can attach this component to a game object to make it the target for locomotion. That means by default, when performing any kind of locomotion, it will move the XR camera rig, right? So this object here, right here, it will be moved. And if you have, for example, a car and your user enters the car and then you parent this camera rig to that car game object, for example, then you can use locomotion target override and add it to your car object, the one that is actually being moved by, let's say, your car controller script or anything. And And then you could theoretically use the locomotion system for that. So you can then use a free locomotion provider to implement smooth free driving, and the locomotion system will actually move your car instead of moving the camera rig. And then when you disable the component or destroy it, it will just move the camera rig again. It's just another way of making the system more useful to different scenarios. So if you have this kind of scenario, you might want to use this target override component. Yeah, so that's what I want to say. And the other component I completely overrun was the smooth locomotion provider, which is really straightforward, but I just want to make sure I give one example of a free locomotion provider. So this is the smooth locomotion provider that implements the base locomotion provider, inherits and implements iFree locomotion provider. And all it does, it just gets a message on input changed, and then it checks if the input action of that input message is the one that we actually configured for in the profile of the smooth locomotion provider. And if yes, then it performs a simple, it moves the locomotion target transform, and that's it. So another example for a really basic and straightforward provider, but that does a great job at what it needs to do. Yeah, and that wraps up my talk about the locomotion system. I hope I could give you some insights in how the system works, but more importantly, how you can use it and what benefit it can bring to your project. So you can use it out of the box as it is. If it works for your project, it will help you reduce the work you need to do a lot. And take a look at the other systems in XRTK as well, and because they might reduce your work even more. After all, XRTK is a cross-platform toolkit, and so you can almost everything it has will work on any mixed reality platform or target. I mean, I'll admit the locomotion system probably doesn't make too much sense in any AR or mixed reality by definition of Microsoft platform like HoloLens. So it's most importantly for VR, I guess. So yeah, thanks for watching, and if you have any questions, please let me know.
Sorry, thank you so much for such an amazing presentation. Dino is actually the co-founder of Code Effect, so it just made sense he was going to teach us a little bit about coding too. So that's very exciting. Thank you so much for that, Dino. I'm going to call you to the stage now. So
Thank
how
you
is
very
it
much.
going, Dino? Thank you so much. Yes, your presentation is amazing. You're definitely the expert there in locomotion. I understand you are also one of the main contributors for XRTK in GitHub, right?
That's right, yeah.
Oh, that's amazing. So we have a couple of questions here. Thank you for your participation. One of the questions that we have is, for somebody who is not expert in Unity, what does provider mean when you refer to the maybe some adaptations that we can make in the coding in regards to providers?
Yeah, thanks for that question. It's just a name really that we decided to use, but provider is essentially just any service. It's any script or module that does a specific task, for example. So usually the the features will consist of a main service, which we call system. And then that system will have any number of sub-services that help it achieve what its purpose is. And we call these subsystems, sub-services, we call providers. So in the example here, the system is the locomotion system, and providers are just different ways of locomotion.
Okay, yeah, that makes sense. Thank you so much. And we have another question from Paul. He's asking, how about free group locomotion? And he is particularly explaining the scenario where, for example, you have a group of a leader, and then he's guiding the group, and everybody is, for example, on rails connected. So you stay in relationship to your group, so have like a reference. But what if you got free smooth locomotion for moving around? What would you say to that idea?
Okay, so I understand it's a networked multiplayer scenario, so that is not covered yet by the locomotion system. But to implement that, you could implement a specific locomotion provider, as discussed in the clip, that makes sure that all the participants they have sort of a guide, which is the main player, I guess. And then you will have to make sure that they only move in a dedicated area or in an area that was specified by the host. And in the end, you will have to maybe implement some resetting, like, okay, if you want everyone to get back to their starting positions, then you will have to force locomote them to the starting position, basically. But yeah, it's a very specific use case, and I can see how it makes sense. It's just not covered by the out-of-the-box locomotion system as of now.
Thank you so much. So again, for someone who is new, there is apparently free locomotion, teleport locomotion, on-rails locomotion. What exactly free locomotion is compared with teleport, and if we can have both at the same time?
Yeah, that's it's an important distinction. It's like 3 categories. Free really means free, so the user is completely free in where he wants to move, so in any direction, etc. So there is no restrictions to how the user can move. Teleport is different. It's not really free, because you can only move to locations that are valid teleport locations, like anchors, as mentioned, or specific areas in your level where you can move. So you are not really free. The developer decides where you can move. And with free locomotion, you can just move in any direction. Of course, sometimes even with free locomotion, developers will make you follow a specific path, or they will, if you leave the level bounds, they will display a warning to go back into the level, and so on. But in essentially, you are free. And on rails is, yeah, you may have seen some of these roller coaster VR applications where you are sitting in a roller coaster. That's essentially on rails, because you are moving on a very specific and predefined path, and there is no way for you to move anywhere else. Yeah.
Okay, that makes sense. I guess you're familiar with that app that many people sometimes talk about, which is called Alice.
I'm sorry, can you repeat?
Have you been familiar with this game that many people talk about that is called Alice?
Alice.
Yeah, like it seems that it has a nice implementation of locomotion. And if you're not familiar, or maybe It's my pronunciation is not very good.
Oh, I get it. You mean Half-Life?
Yes.
Yeah,
So
yeah.
so it seemed, yeah. And so what are the elements there that we can learn from that are so great? It's as an example.
Yeah, that's a that's a very good question. It depends always on the user, but I think uh, one of the main issues with locomotion today is still motion sickness and VR sickness when people just don't feel comfortable with moving, even though their body is not moving. So free locomotion is an example of type of locomotion that many people will have issues with, because it's like you are sliding around but you're not really moving. So I think in that game they cover for that with different tricks that this locomotion system does not implement yet, but there is stuff like narrowing down the user's uh, viewport, so he can't, whenever he moves, it's like a vignette effect that reduces the user's view. These kind of things can help to reduce issues with locomotion. And what I did in this example is that for teleportation, at least, we have blinking, which helps already a lot with the issues people might have, because with instant teleport will just instantly move you somewhere else, and this can cause issues for people. But blinking will be one example of helping people get comfortable with it. Yeah.
Yeah, that sounds familiar. Yes, so what do you wish I had asked you today? Or what do you wish somebody else had asked you today?
Well, I was hoping, my main goal with this session is to spark interest in XRTK and to make people check it out. So any questions I can get about XRTK in general, that's what I was hoping for, or am hoping for. I'm available in the Discord, of course, and so let me know if there's any more questions. The toolkit is available, and using it can help you speed up your mixed reality development a lot. And yeah.
Okay, yeah, that has been such a great presentation. Locomotion is definitely a very sensitive topic for user experience. So there you go. We had such a great direct illustration there from you about how to correctly maybe use or have some good fundamentals for the implementation of the right locomotion. Thank
Yeah.
you so much, Dino. Really, really grateful for your participation. Thank you so
Thank
much.
you as well. Thank you very much.
Yeah. Thank you and see you around. I invite everybody to follow Dino in social media and to visit his website. What's your website, by the way, before we go?
I don't really have a website at this
Mhm.
point. I just, my GitHub profile and
Yeah.
Twitter is where I'm mostly at.
Okay, for sure. They can find you as what's your username?
Oh, it's DIN then OM1TE. But I think it's the easiest way is to find me on Discord using my real name, or in the recording of this session, you can find at the end of the clip, you can find all my handles.
Okay.
Yeah.
Thank you so much, Dino. Have
Thank you as
an
well.
amazing day. Goodbye, everybody.
Thank you. Thank you.